Hi, Assalamualaikum and good morning everyone. So in today's lecture, we will continue with definition of the other enthalpies. So we have covered definition for enthalpy of formation together with the respective examples. So in today's lecture, we will continue with enthalpy of combustion, atomization, neutralization, hydration, solution, sublimation, and bond energy or bond enthalpy. So again, what you really need to know regarding these enthalpies are you need to know the definition, okay, of each one of them very well. And then from the definition itself, later on, you must be able to write its thermochemical equation. Okay, so in thermochemical equation, be sure you can write the chemical equation and also the enthalpy values. Standard enthalpy of combustion, delta H naught C, or enthalpy of combustion, delta HC. So what is the difference between standard enthalpy and enthalpy of combustion is the condition of the reaction. If the reaction is done under standard condition, so hence the name of the enthalpy will be standard enthalpy of combustion, delta H naught C. So in this lecture, I am focusing on standard enthalpy of combustion, okay, whereby the combustion reaction at standard condition. Okay, so what is the definition for standard enthalpy of combustion? It is actually the heat released. Okay, combustion is a reaction, okay, is an exothermic reaction that released certain amount of energy. So standard enthalpy of combustion is the heat released when 1 mole of substance is completely burned in excess oxygen under standard condition, which is at 298 Kelvin and 1 atm. So you have to be sure in any of the definition for enthalpy of specific reaction, you must be very sure, okay, which part of the equation that can has the 1 mole. Okay, so which 1 mole we should refer to, whether it is on the reactant part or the product part. So in this case, from this definition, okay, it is clearly that where the heat released when 1 mole of substance is completely burned in excess oxygen, so we can say that this 1 mole must be at the reactant, okay, because we are going to burn the reactant in excess oxygen. Okay, so for example, this is the enthalpy combustion value for carbon. Okay, carbon or carbon graphite. So the combustion of this carbon will release this amount of energy. Okay, and for this value, it is stated that negative 393 kilojoule per mole. So from this kind of values, okay, it is giving us information that in order to burn this carbon, this reaction will release, negative means release, 393 kilojoule of energy. This per mole is actually referring to burning of 1 mole carbon. Okay, so this is the abbreviation. Okay, and for the sentences, if you convert this abbreviation into sentence, so it will become combustion of carbon at standard condition releases 393 kilojoule of energy. So what you really need to know from this abbreviation and this statement is you must be able to write back the thermochemical equation. So by having these two informations, whether the first one or the second one, okay, you must be able to write the thermochemical equation. So from that information, we can have, since we have carbon to be burned in this example, so when we burn the carbon in the form of solid, so burn with what? We will burn with oxygen gas. So you will get carbon dioxide as the product. Okay, so again, please refer to the definition. So where should we put the 1 mole? So the 1 mole will be on the substance that we burnt. So in this case, we will burn carbon. So the 1 mole should be on the carbon. Okay, so it is not necessary for you to put the value of 1, okay, in front of the carbon, of course. All right, so I'm just showing you the example. Okay, I'm just showing you where we should put the 1 mole, okay, in this thermochemical equation. So the 1 mole must be on the substance that we burnt, which is carbon. All right, now, so by having this equation, so next you are going to write the full thermochemical equation. So in order to have a full thermochemical equation, we need to have a balanced chemical equation together with the enthalpy value. Right? So since this reaction, okay, is done for 1 mole of carbon burned in oxygen, so hence the delta H not combustion will be negative 393 kilojoule. So please remember, in thermochemical equation, the enthalpy unit will be in kilojoule, not kilojoule per mole. Why? Because we already fixed the 1 mole on the specific part of the reaction. We have fixed the 1 mole for substance burn. So that's why you really need to know, okay, which of the substances in the chemical equation that will set as 1 mole. Okay, so after that, you can write the full thermochemical equation, and the unit for the enthalpy must be in kilojoule because we already set our balanced equation, okay, which one should be the 1 mole. Okay, so let's study the example of question that related to standard enthalpy of combustion. So as in this question, you are needed to calculate the standard enthalpy of combustion for reaction below. Okay, so it is mentioned to you that this reaction given in the question is combustion reaction. And you are needed to find the standard enthalpy of combustion for the given reaction by using this given standard enthalpy formation values. So we have standard enthalpy formation for carbon dioxide, water, and methanol. Okay, so in this soalan, since you are needed to find standard enthalpy of combustion, and you also have the standard enthalpy formation for this reactant and these two products, so hence, in order to find the standard enthalpy of combustion, you can use the same formula that we used in the previous, that is summation formula. Okay, so what is the difference in this question with the previous? In the previous question, if you still remember, you are needed to find standard enthalpy of reaction, meaning that we didn't know what is the specific reaction that you are going to calculate for the previous example. Okay, so you are given a random reaction and you are needed to find the standard enthalpy of that reaction. Okay, since we didn't know what is the specific reaction in the previous example, meaning that we cannot refer to 1 mole of any substances in the chemical equation. So hence our final answer for standard enthalpy of reaction in the previous example will be recorded in the unit of kilojoule. But if you are certain with the type of the reaction, for example, combustion reaction, so hence you can find the specific standard enthalpy of reaction. So like in this question, since you know that this equation is combustion equation, okay, so you are able now to find standard enthalpy of specific reaction, that is combustion. So according to the previous slides, you have seen the definition of the standard enthalpy of combustion, whereby this standard enthalpy of combustion will refers to 1 mole of substance burned in excess oxygen. So the 1 mole will be on this reactant. So anytime we have 1 mole to be referred to in our definition, so your final answer for that standard enthalpy of combustion later will become kilojoule per mole. Okay, why it is per mole? Because we are referring to 1 mole according to the definition. And again, since you've been given this value enthalpy formation for all substances over here, So in order to find enthalpy of this specific reaction, which is combustion, you can still using summation formula. Okay, but again, in this question, you are not given the standard enthalpy formation value for oxygen. Okay, so since oxygen is naturally exists in nature, so the value of delta H naught F for oxygen will be 0. Alright, so let's work out with the calculation. So before you start doing any calculation, please make sure you have to check for the balancing. Okay, so take some time to check for the balancing. Is this equation balanced? Okay, the answer is yes. So we already have a balanced chemical equation for combustion reaction. So now you are going to find standard enthalpy combustion for this reaction. So by using summation formula, so now you will start with standard enthalpy combustion. Okay, it is no more standard enthalpy reaction because we already know what is the specific name of the reaction, that is combustion. So you may label the standard enthalpy reaction as standard enthalpy combustion. Okay, so you will be using the same formula. So you have to make sure every time if you have standard enthalpy formation values given in the question for all reactants and product, you can always use summation formula to find any enthalpies of reaction, whether it is combustion, whether it is neutralization, and so many reactions. Okay, as long as you have the value of standard enthalpy formation for all substances. But if you are being asked to find enthalpy of reaction, okay, but you be given the value other than standard enthalpy formation, okay, in that case, you are no longer valid to use summation formula. Why? Because summation formula can only be used if we have standard enthalpy formation, okay, for all products and reactants in our question. Okay, formation only. So only formation values can be used in this summation formula. Okay, other than that, you cannot use summation formula. So please bear in mind. Okay, so we have carbon dioxide as the product. So carbon dioxide is in 1 mole.
So we have 1 mole of carbon dioxide times its standard enthalpy formation value. So it is 393.5 kilojoule over 1 mole plus another product enthalpy, which is water. So water we have 2 mole. So water in the form of gases having the value of -2 for 1.8 kilojoule over 1 mole. Okay, so we have done with the product. So now we have to minus with the reactant. So for the reactant we have 1 mole of the methanol with -201.5 kilojoule over 1 mole plus oxygen, which is 0. Okay, so from here you can cancel this unit. Okay, and you can calculate the answer. So the answer is -675.6 kilojoule.
Okay, so now, is this the final answer for enthalpy of combustion? The answer is no. Why? Because standard enthalpy of combustion is heat released when 1 mole of substance burn in excess oxygen. So now, we have referred that definition just now to 1 mole of something. So in order to get the final answer for standard enthalpy of combustion, so by using the values you got from the previous calculation, so we have to divide with 1 mole. Okay, so where this 1 mole comes from, it is actually comes from this balancing equation. Okay, so we have already set this methanol as 1 mole. Okay, so you are going to divide this value, okay, that you have calculated previously, and you have to divide with 1 mole. okay, of the methanol burned just now. So your answer will be negative 745.6. It is the same figure but in unit kilojoule per mole. Why we need to have this per mole? Because in this standard enthalpy of reaction, we do know the specific reaction. Okay, we do know the specific reaction, iaitu combustion. So for any kind of soalan, if you know the specific name of the reaction, so your final answer of the enthalpy must be in kilojoule per mole. Alright, now, so when you are about to write its thermochemical equation, so again, CH3, OH, okay, burning carbon and hydrogen compound, you will get carbon dioxide and water as the product. Okay, so please be sure with the balancing. So make sure everything is balanced. So here will be 3/2. Okay, so after you have completed writing the balance equation, so in order to have a full thermochemical equation, so don't forget to put the value of the enthalpy. So standard enthalpy combustion value equals to negative 675.6. Sorry, I don't have any space up here, so I will just write my unit, okay, below of the enthalpy. So in thermochemical equation, please bear in mind, in thermochemical equation, the unit will only be in kilojoule. Why? Because we have set the 1 mole, okay, in this balancing equation. Alright, but when you are finding the value of enthalpy combustion here, so the value here must be recorded until kilojoule per mole. But when it comes to thermochemical equation, okay, since you have set this 1 mole substance burn in excess oxygen, so this unit must be remains in kilojoule only. Standard enthalpy of atomization, delta H naught A, states that the heat must be absorbed when 1 mole of gaseous atom is formed from its element under standard conditions at 298 Kelvin and 1 atm. So for this reaction, the enthalpy must be in positive because this reaction is an endothermic reaction, heat absorbed. So delta HA is always positive because it involves only breaking of bond. So in order to break the bonding, so that reaction must requires certain amount of energy. Okay, so according to this thermochemical equation, okay, we can see that the 1 mole will be on product part. Okay, sebab according to the definition, it is the heat absorbed when 1 mole of gaseous atom is formed, okay, from its element. So this is the element, okay, and this is the gaseous atom form, okay, under standard condition at 298 Kelvin and 1 atm. Okay, so this definition has these two conditions because the name is standard enthalpy of atomization. If the name is enthalpy of atomization, so these two conditions could be at any pressure and temperature. So that is the difference between standard enthalpy atomization, delta H naught A, and enthalpy of atomization, delta H A. Okay, so now you are about to write the thermochemical equation, okay, for standard enthalpy of atomization. So for any definition that we have learned in this lecture, you must make sure you are able to rewrite, okay, the sentences. You must be able to rewrite the thermochemical equation, okay, from the information given. So from there, it is one of the bukti lah, okay, it is one kind of proof yang you dah faham, okay, what is the meaning and how to convert the meaning into the thermochemical equation. Okay, so let's see this example. Suppose that we have 1, 2, 3 kilojoule of energy is released when chlorine gas atomizes at standard condition. Okay, sorry, it is not energy release, it is energy absorbed. Okay, so 1 to 3 kilojoule of energy absorbed when chlorine gas atomizes at standard condition. So you can see that chlorine gas is chlorine in the form of gases. In nature, chlorine gas exists in the form of Cl2 gas. Okay, atomized meaning that this chlorine gas, Cl2 gas, is a molecule. So the molecule will break its covalent bonding to form gaseous atom. Okay, so in nature, chlorine gas exists in the form of molecule. So when I say molecule, meaning that we have Cl and Cl. So these two Cl are connected. Okay, these two Cl atoms are connected by this single covalent bonding. So when this molecule atomizes, meaning that the energy absorbed will be used to break the bonding over here. So when this bond break, so in the product part, you will have Cl, gaseous atom. So this is molecule and this is atom. So you can have one Cl and another one Cl. So the total of Cl atom will be 2 Cl atom. Okay, now, so when you are about to write the thermochemical equation for this reaction, so what reaction is this? From chlorine gaseous molecule, break the bonding and forming the gaseous atom, definitely this will be atomization reaction. So in order to write the standard enthalpy atomization equation for this reaction, okay, so you must refer back to the definition. So according to the definition, it is stated that standard enthalpy atomization refers to 1 mole of gaseous atom formed from its element under standard condition. So in this case, which part should be the 1 mole? Molecule or atom? The answer will be atom. Okay, sebab according to the definition adalah standard enthalpy of atomization is the heat absorbed when gaseous atom, when 1 mole of gaseous atom form from its element. So in this case, you have to make this part, okay, the gaseous atom part ini, okay, you have to make it 1. Okay, you have to make it 1. So in order to make it 1 for the product part, so what you have to do is you have to divide with 2. Ini pun divide with 2. So finally you will get half Cl2 gas molecule atomized to form 1 mole gaseous atom. Because according to this standard enthalpy of atomization, 1 mole must be on the product part. Okay, 1 mole of gaseous atom formed from its element. Okay, so now, so 1 to 3 kilojoule of energy is actually energy needed or absorbed in order for this reaction to happen. Okay, so when half of Cl2 breaks its bonding, okay, in the same molecule, so this reaction will absorb this amount of energy to form 1 mole of this gaseous atom. So the enthalpy of this reaction, delta H naught A, if it is standard, so just put naught. Okay, so the energy will be plus 1 to 3 kilojoule. So again, in thermochemical equation, okay, the unit, okay, will be restricted in kilojoule only. Why? Because we already set this equation, okay, to be 1 mole on the product part. Alright, but in some of the soalan, okay, in certain type of soalan, when the question give you the values of the standard enthalpy of atomization, so the abbreviation will be given like this: delta H naught Cl, okay, is 1, 2, 3 kilojoule per mole. Alright, so meaning that you have to understood this is standard enthalpy of atomization, okay, which refers to 1 mole of gaseous atom formed over here, and this reaction, okay, dah refer to 1 mole, and this reaction akan requires this amount of energy. The next one will be enthalpy of neutralization. Okay, so if it is standard enthalpy of neutralization, so your symbol will be delta H not neutralization. Okay, if this is enthalpy of neutralization, so the symbol will be delta H neutralization. So what is the difference between these two names just now that I have mentioned to you just now? So for standard enthalpy of neutralization, if you have standard over here and we have one symbol not over here, so that reaction is actually being done under standard condition, which is at temperature 298 Kelvin or 25 degrees Celsius and at 1 atm. Okay, but if it is enthalpy of neutralization, delta H neutralization like this, so this reaction can be done under any stated condition, meaning that at any temperature and pressure other than 298 Kelvin and 1 atm. Other than that, okay. So what is enthalpy of neutralization? It is the heat released when 1 mole of water is formed. So now the 1 mole is actually on water forming from the reaction. Okay, so the heat released when 1 mole of water is formed from the neutralization of acid and base under stated condition. So why standard condition? Okay, because we didn't refer to standard enthalpy of neutralization. We just refer to enthalpy of neutralization sahaja. Okay, which is can be done under any temperature and pressure. Okay, so the value of the enthalpy will always be in negative. Okay, why negative? Because according to the definition, this reaction is an exothermic reaction, heat released. Okay, so when you are writing the thermochemical equation, okay, so for example, reaction neutralization between HCl and sodium hydroxide, you will get this salt, sodium chloride and water. Okay, so this reaction will release energy sebanyak negative 58 kilojoule. Okay, so this energy is actually energy released when these two acid and base reacts, forming 1 mole of water. So in order to write your thermochemical equation, you have to make sure this water must be in 1 mole. Okay, you have to balance this equation until you get 1 mole for the water. Okay, so what does it mean by having this thermochemical equation? So it means that when you do the ratio, so if we have 1 mole of HCl, so 1 mole of HCl is equivalent to 1 mole of sodium hydroxide, also equivalent to 1 mole of NaCl, also equivalent to 1 mole of water, and all of this also equivalent to negative 58 kilojoule. Okay, so meaning that, okay, by doing this kind of ratio, okay, instead of knowing how much energy released for the formation of 1 mole of water, you can also find how much the energy associated with the HCl, sodium hydroxide and NaCl. Okay, so you can simply do the ratio like what you did in the chapter 1 semester 1. Okay, let's see another example. So suppose that we have this statement, reaction between sulfuric acid and potassium hydroxide releases 54.6 kilojoule of energy. Okay, now if I ask you to write the thermochemical equation for this reaction, so first of all, you have to write the balancing equation for this neutralization reaction. So we have H2SO4 reacts with potassium hydroxide. So reaction between these two, you will get potassium sulfate and water. Okay, so now you have to check for the balancing. So according to the balancing, we will have 2 in front of water. Okay, now, so if you are about to do thermochemical equation for this neutralization reaction, you have to bear in mind, according to our definition just now, this reaction is the heat released when 1 mole of water formed from neutralization reaction between acid and base. So, in order to have a correct thermochemical equation, you have to make sure this water must be in 1 mole. So what you can do is, you have to divide all of this with 2. So hence your new thermochemical equation will be like this. And 1 mole of water. So after you have got the 1 mole for water, so next you proceed writing the enthalpy values. So if this reaction is done under standard condition, so hence you need to have the not symbol, okay, on top of the H. Okay, if this reaction is done under non-standard condition or under stated condition, so you may just leave your symbol as delta H neutralization. Okay, so this reaction will have energy as much as negative 54.6. Again, the unit must be in kilojoule. Why kilojoule only? Because we already set the 1 mole on the water. So next will be enthalpy of hydration, delta H hydration. So enthalpy of hydration is the heat change when 1 mole of gaseous ion is hydrated in water or aqueous solution under stated condition. So again, okay, if you are talking about standard enthalpy of hydration, so your condition will be 298 Kelvin and 1 atm. Okay, and if you are talking about enthalpy of hydration, so the condition could be in any pressure and temperature. Okay, now from the definition, so let's look at the 1 mole. So 1 mole according to this definition is referring to 1 mole of gaseous ion hydrated. Okay, gaseous ion hydrated. So which one is our gaseous ion? So the gaseous ion is actually on the reactant part. Okay, so in order to write your thermochemical equation, you have to make sure, okay, you have to balance the equation until the gaseous ion is in 1 mole. Okay, so 1 mole should be refers to reactant part. So when this 1 mole of gaseous ion, okay, is hydrated, ataupun is being put in any aqueous solution, so it will become sodium ion aqueous. Okay, so you can see what happens between these two is actually the phase transition from gaseous to aqueous. Okay, so according to this enthalpy of reaction, this reaction release as much as 406 kilojoule of energy. Okay, so let's see another example. 363 kilojoule of energy is released when 1 mole of gaseous chlorine ion hydrated. Okay, so meaning that from this statement and from this abbreviation, in order to write the thermochemical equation, so again you have to identify, so which 1 mole, okay, should be in the thermochemical equation, whether it must be on the reactant part or the product part. Okay, so since this is hydration reaction, so you have to start with gaseous ion. So our gaseous ion is Cl minus gas. Okay, so the 1 mole should be on this gaseous ion. Okay, so it doesn't matter, you don't have to write the 1, okay, in this balancing sebenarnya. Okay, so I just want to show you where is the 1 mole according to this equation. Okay, so this Cl minus, when it is hydrated, so you will get Cl minus aqueous. Okay, so this happens during hydration process. The gaseous ion will become aqueous ion. Okay, so you don't have to put 1, okay, in this thermochemical equation. And then the delta H hydration will be negative 363 kilojoule. Okay, so again, why it is not 1 mole, why it is not per mole? Because we already set the 1 mole in this reactant, okay, according to the definition as well. Enthalpy of solution or solvation or dissolution. So according to this enthalpy, it is heat change when 1 mole of substance is dissolved in water to form dilute solution under stated condition. So Heat change when 1 mole substance dissolved in water. So this statement should refers to reactant. Okay, this statement should refers to reactant. So when 1 mole of this reactant dissolved in water, okay, so before that, the reactant must be in the form of solid or crystal. Okay, meaning the ionic form lah. Okay, any ionic form of the reactant. Okay, ionic form of the reactant. So when the ionic reactant dissolved in water, so you will get aqueous ion. Okay, so in enthalpy of solution, it refers to 1 mole of this ionic crystal dissolved in water, okay, or undergoes dilution process, okay, in order to form these two aqueous ion. Okay, but the 1 mole should be refers to reactant part, iaitu ionic compound. Okay, so solution of this ionic compound, okay, according to this equation, thermochemical equation, so dissolving this ionic compound will require this amount of energy. Okay, so this energy is actually associated with 1 mole of KCl and 1 mole of K plus and 1 mole of Cl minus. But according to this definition, this 1 mole should be refers to KCl. So when you are doing the thermochemical equation, so for the balancing equation, you have to make sure the 1 mole must be on this reactant part. Okay, so let's see another example. Heat absorbed when 1 mole of sodium ethanoate dissolved at standard condition is 19.7 kilojoule. Okay, so now you are going to write the thermochemical equation for this statement. Okay, again, so this sodium ethanoate is one example of solid compound, okay, of ionic compound. Alright, so when this ionic compound dissolved in water, so ionic compound, the fasa must be in solid. So when this ionic compound is dissolved in water, so you will get CH3. Okay, ethanoate ion. Okay, dissolved in water. So water, the fasa must be in aqueous. Okay, the ions later will be in aqueous. And Na plus. Aqueous. Okay, why aqueous, not gas? Because we dissolve in water. Okay, so the gases, the ions akan be coming in the form of aqueous. So the enthalpy of solution will be 19.7 kilojoule. Okay, so why we didn't write in kilojoule per mole? Because we have fixed this equation, the 1 mole should be on this solid crystal. Okay, iaitu reactant. Next is enthalpy of sublimation. So enthalpy of sublimation refers to the heat absorbed when 1 mole of a substance sublimes under stated conditions. Okay, so 1 mole of substance sublimes. This statement should refers to this reactant. So when 1 mole of this reactant sublimes, okay, to form the gaseous product, so this reaction will absorb 106 kilojoule of energy. So according to enthalpy of sublimation, the 1 mole must be referred to reactant. Okay, the last one will be bond energy or bond enthalpy. So according to this enthalpy, it is mentioned that energy needed to break 1 mole of covalent bond under stated condition. Okay, so since this reaction involves breaking of covalent bonding, so obviously there must be certain amount of energy needed, okay, for this reaction to occur. So hence this is one example of the endothermic reaction. Okay, so let's see the example given in this slide. So we have the oxygen gases molecule on the reactant part. Okay, so this is the oxygen molecule. And we have the gaseous oxygen atom on the product part. Okay, now, so when we are talking about breaking the covalent bonding, so if you can see from this chemical equation, we have atom as the product and molecule as the reactant. So obviously, we have the covalent bonding in this reactant because this reactant is in the form of molecule. Okay, so O2 molecule meaning that we have two oxygen atoms connected by single covalent bonding. Okay, so according to this bond enthalpy or bond energy, it is energy needed to break 1 mole of covalent bond. So since we have the covalent bond in this reactant part in this molecule, so the 1 mole must be referred to reactant. Okay, so when you are about to write the thermochemical equation later on, so you have to make sure you have to fix the 1 mole on the reactant part, which is on the molecule. So the breaking process between these two oxygen atoms, okay, then you will get 2 oxygen gases. Okay, so in this molecule, when we break the covalent bonding between these two atoms, okay, in this molecule, so hence you will get 2 gases atom of molecule. So to simplify your answer, we will write as 2 oxygen gases atom. Okay, so according to this reaction, it involves 498 kilojoule, meaning that this is the amount of energy absorbed or must be absorbed by this 1 mole of reactant molecule to form 2 mole of gases oxygen atom. So the 1 mole must be referred to this reactant part. Okay, if we take other example such as chlorine gas, okay, so now you are about to write the thermochemical equation, okay, for bond energy of chlorine molecule. So chlorine molecule is Cl2 gas. So Cl2 is in the form of molecule. Okay, so when this molecule, okay, we treat with this reaction, yaitu bond energy or bond enthalpy. So what happened is the energy or the bond energy, okay, will be absorbed by the chlorine gases molecule to form chlorine gases atom. Okay, so again, where should we refer as 1 mole? The answer is on this reactant part, because in this reactant, it has covalent bonding, and the bond energy is about to break 1 mole of the covalent bonding. So the 1 mole must be fixed on the reactant part, and enthalpy of this reaction, the value is 243 kilojoule of energy. So to break 1 mole of this covalent bonding in Cl2 gases molecule, this reaction must absorb this amount of energy in order to form 2 Cl gases atom. So this example, okay, if you still remember, this example is quite similar to what we have done in enthalpy of atomization. Okay, but those two are different. Enthalpy atomization and bond energy are different. Okay, they are differ from each other. Why? Because in each enthalpy of reaction, for atomization, it must refers to 1 mole of gases atom form. In bond energy, we have refers to 1 mole of covalent bonding break. Okay, so the 1 mole for that specific reaction, okay, is different. Okay, it is not the same lah. Right? So that's why in order to write thermochemical equation, for certain reaction, you must specifically refers to what is the enthalpy of the reaction and what is the 1 mole, where is the 1 mole, okay, stated in its definition. So by having or by knowing the name of the enthalpy and the definition of the enthalpy, you will be able to rewrite the thermochemical equation later on. So hopefully you have enjoyed learning the new concept today. So as we have come to the end of the lesson, by now you should be able to identify the reaction, their 1 mole, and also you should be able to write the correct thermochemical equation. So this concept will be further used in the next lesson. So have a pleasant day everyone. Bye!